Dear students, I would like to share with you how we can derive the raw moments of the normal distribution from its MGF. Of course, by raw moments, I mean expected value of x, that's the first raw moment, expected value of x square, that is the second raw moment, and so on. Of course, आप समझ गए होंगे कि raw moment कहें या moment about zero या moment about the origin, ये सब जो terms हैं, they are meaning the same thing. All right, let us go about it. What do we have to do? First of all, we have to derive or pick up the expression of the MGF. Then we have to take the first derivative and put t equal to 0. That will give us the expected value of x, first raw moment. And then we take the second derivative and put t equal to 0. That gives us the second raw moment, that is expected value of x square, and so on. All right? So therefore, we can start now as follows. The MGF of the normal distribution is well known all over the world, and it is given by mt is equal to e raised to mu t plus half t square sigma square. अब इसका फर्स्ट डेरिवेटिव ले लेते हैं. m dash t is d by dt of e raised to mu t plus half sigma square t square. अब इसमें how do we get the derivative? E raised to anything का derivative क्या होता है? That same expression multiplied by the derivative of that expression which we have in the power or in the exponent. So, as you can see on the screen, we get e raised to mu t plus half sigma square t square into d by dt of mu t plus half sigma square t square. So that is mu plus half sigma square into 2t, because t square ka derivative obviously 2t. And then of course the 2 cancels out with the 2 in the denominator, and we get inside that bracket mu plus sigma square t. अब ये जो पूरा एक्सप्रेशन है इसमें t को 0 रख देते हैं. So what do we get? m dash 0 is equal to e raised to mu into 0 plus half sigma square into 0 square, and this whole thing multiplied by mu plus sigma square into 0. तो students obvious है कि e की power में we have 0 plus 0 और उसके साथ जो multiplied है that is mu plus 0. So e raised to 0 into mu is 1 into mu, and that is equal to mu. So therefore, we have found that the expected value of x, the first raw moment of the normal distribution, is equal to mu. ये वैसे भी derive किया जा चुका है और बड़ा आसानी से कर सकते हैं. Straight जो definition है expected value of x की, उससे भी mu ही आंसर आता है. और अब इस वक्त हमने MGF के थ्रू भी देखा कि it is equal to mu. इसके बाद let's go for the second derivative of mt. So obviously m double dash t is d by dt of m dash t, and after that you can substitute the expression of m dash t and do all the steps step by step by step, which are in front of you on the screen. And you can see that it's quite a lengthy expression actually. लेकिन उसके बाद जब हम उसमें t को 0 पुट करेंगे तो हमारे लिए काफ़ी आसानी हो जाएगी, क्योंकि कई टर्म्स 0 ही के बराबर हो जाएंगी. So what do we get when we do put t equal to 0? We get m double dash 0 is equal to mu square into e raised to mu into 0 plus half sigma square into 0. And this whole thing is to be added to mu into sigma square into 0 into e raised to mu into 0 plus half sigma square into 0. अभी ये पूरा नहीं है, उसके बाद plus another lengthy expression, and you can put all the zeros wherever you have to put them yourself. Also, it is in front of you on the screen. अब उसको जब हम simplify करते हैं, तो what do we get then? It comes out to be equal to mu square into e raised to 0 plus 0 plus sigma square into e raised to 0 plus 0 plus 0. So therefore, it is simply mu square into 1 plus sigma square into 1, यानी mu square plus sigma square. तो ये क्या चीज हमने निकाली है जी? We have found the second raw moment, that is the expected value of x square. Mu square plus sigma square. That's what it is. और अब we are wanting, I am at least wanting to find the variance, क्योंकि variance का shortcut formula जो है उसमें यही raw moments तो इस्तेमाल होने हैं. So what is the formula? As you know, variance of x is equal to the expected value of x square minus the expected value of x whole square. So अभी जो निकाला है उसमें put कर दें. So it is equal to mu square plus sigma square minus mu square. So obviously mu square minus mu square is equal to 0, and we are left with sigma square. Once again, आपने देखा कि MGF के थ्रू भी जब हमने चीजें निकाली तो वेरिएंस ऑफ x came out to be sigma square, exactly वही जो कि अगर आप डायरेक्ट मेथड से वेरिएंस निकालें तो आपको जो रिजल्ट मिलता है. So this is how the MGF of the normal distribution can be utilized to find the raw moments. All the higher moments, higher raw moments, expected value of x cubed, expected value of x raised to 4, and so on, जहाँ तक आप जाना चाहें, they can be derived in a similar manner.